Andalus BIMEX presents MBBR Wastewater Treatment Plant. Process Walkthrough. Wastewater from communities flow to underground equalization tank. These tanks come with two pumps, both controlled with lever switches, mounted inside these tanks. The sump comes with a control panel that controls the pumps based on signals received from the level switches. The first level switch triggers the first pump, and the second level switch triggers the second pump. The third level switch sends out a high-level alarm signal. The purpose of this large equalization tank is to collect the sewage that flows by gravity from the communities. The wastewater is pumped from the collection tank into the wastewater treatment plant. There are coarse and fine screens above the receiver tank to remove coarse and fine material that may damage process equipment downstream. These screens require periodic manual cleaning. The screen wastewater drops from the screening box into the receiver tank. Air is provided to the receiver tank to keep the raw sewage aerobic and well mixed. Air diffusers and air blowers provide the air required. Then the fluid transfers to the anoxic tank. Return sludge from the secondary clarifier mixes with the raw sewage in the anoxic tank for denitrification. In the absence of oxygen, the bacteria break down nitrates and nitrites generated in the aeration tank to oxygen and nitrogen gas. This process is known as denitrification. The oxygen is absorbed by the bacteria in the return sludge. The bacteria uses the raw sludge as a carbon source, food for metabolism and growth. And with low dissolved oxygen, the nitrates and nitrites are used as an oxygen source for the bacteria. The aeration tank is the heart of the biological process, where BOD removal and nitrification conversion of ammonia to nitrate takes place. Aeration is provided using air diffusers and air blowers to supply the required air. Almost half of the aeration tank is filled with biomedia to increase the biomass population in the aeration tank, thus reducing the required footprint. The biomedia is made of polyethylene and has a large surface area that houses many different kinds of microorganisms population needed for the wastewater treatment. The biomedia has a density slightly less than water and will float in water. The aeration system causes the biomedia to be mixed into the water and supplies the required amount of oxygen the bacteria needs to grow and thrive and consume the organic waste coming with the wastewater stream. To ensure that the biomedia stays inside the aeration tank, a perforated screen is used to retain the biomedia and transport the wastewater to the secondary clarifier. Fluid from the MBBR aeration tank flows to the secondary clarifier. As the water flows aboard, the sludge stays on the hopper place and slide downward and into the bottom of the hopper. It is in the clarifier that the fluid stream is separated into water and sludge. The mostly solid-free water rises to the top of the clarifier and out the top to the next treatment stage. Most of the suspended solids settle in the clarifier, leaving behind clear water, a small amount of solids based through the clarifier, which is then filtered out in the sand filter. The sludge settled at the bottom is transferred by air left back to the anoxic tank. The flow through this airlift can be controlled by adjusting the opening of the valve. A portion of the sludge is wasted out of the unit as required by closing the sludge recycle valve and opening the sludge wasting valve. Then the water flows into tertiary filtration through a sand filter to remove any remaining solids. The water then flows through an activated carbon filter to remove any odors from the fluid. Then the fluid enters the chlorine contact tank for disinfection. This tank provides enough retention time for the disinfectant to take effect. Chlorine dosing pumps supply the required amount of chlorine to kill pathogens and other harmful organisms in the water. The automated dosing system is located in the control room. The fluid then runs through an ultraviolet light for a higher degree of disinfection. The ultraviolet radiation causes damage to the genetic structure of bacteria, viruses and other pathogens, making them incapable of production. The extra sludge from the clarifier is ejected from the MBBR unit to the drying beds for recycling. The output water is then discharged out of the unit and is ready to be reused. Advantage. The MBBR wastewater treatment unit does not allow the transfer of pollution from one place to another. The MBBR unit reduces the cost of the wastewater treatment as it does not need the high cost of pumping stations and long pipelines. The MBBR unit considered as one of the most advanced types of treatment, as the output water quality is as near as drinking water, thus it can be reused for other purposes. The small size of the MBBR unit minimizes the cost of transportation, setup time and effort. The number of persons needed to operate the MBBR unit is very minimal. It also saves the effort expropriation of the lands. This requires establishing conventional secondary wastewater treatment plants. Finally, Andalus BIMEX MBBR unit is manufactured completely in our factories, which makes it 100% Egyptian made.